Okay, welcome my dear students. Today we are going to solve the problems in the exercise 3.6 and mainly we are going to apply the identities from product to sum to product. So you have to recall that sin A cos B equal to 1 by 2 sin A plus B plus sin A minus B. Cos A sin B equal to 1 by 2 sin A plus B minus sin A minus B. Cos A cos B equal to 1 by 2 into cos A plus B plus cos A minus B. Sin A sin B equal to 1 by 2 cos A minus B minus cos A plus B. In that identities, if we replace A plus B by C, A minus B by D, then A becomes C plus D by 2 and B becomes C minus D by 2. Again, the formula is converted into sum to product. Okay, so we are going to use that identities. So question number 1 in the exercise 3.6, express each of the following as sum or difference. First subdivision, sin 35 degree cos 28 degree. Okay, second subdivision, sin 4x cos 2x. Third one, 2 sin 10 theta into cos 2 theta. So there are 5 subdivisions. Let me solve the first 3. So look at that. First one, sin 35 degree cos 28 degree. So it is of the form sin A cos B. Sin A cos B is 1 by 2 into sin A plus B plus sin A minus B. So 1 by 2 sin, consider this is A and this is B. So 35 plus 28 degree plus sin 35 minus 28 degree. Okay, so 1 by 2 into sum of that 3. Okay, so sin 3 remaining 1, so 63 degree plus sin, what is that, remaining 7 degree. Second subdivision, sin 4x cos 2x. Again the same formula, sin A cos B equal to 1 by 2 sin A plus B plus sin A minus B, the same thing. So in the place of A we got 4x and the place of B we got 2x. So sin 4x plus 2x plus sin 4x minus 2x. So 1 by 2 sin 6x plus sin 2x. That is the answer. Product to sum. Okay. Third subdivision, 2 sin 10 theta cos 2 theta. Okay, so 2 into, again the same formula, sin A cos B. So 1 by 2 into, okay, so 1 by 2 into sin A plus B. So 10 theta plus 2 theta plus sin 10 theta minus 2 theta. So the 1 by 2 cancel. So sin 12 theta plus sin 8 theta. So fourth subdivision in the first question, it is of the form cos A cos B. So cos A cos B is nothing but 1 by 2 cos A plus B plus cos A minus B. So cos A plus B, A is 5 theta, B is 2 theta. So 5 theta plus 2 theta plus cos 5 theta minus 2 theta. Okay, so 1 by 2 cos 7 theta plus cos 3 theta. You have to remember the identity. So next one, fifth subdivision, it is of the form sin A sin B. So it is 1 by 2 cos A minus B minus cos A plus B. So 1 by 2 cos A minus B minus cos a plus b. Okay, so 1 by 2 cos theta minus cos 9 theta. 2 in the exercise 3.6, the question is express each of the following in the form of product. It may be in the form of sum. Our aim is to find out into the product form. So it is of the form sin c minus sin d. So it is nothing but 2 cos c plus d by 2 into sin c minus d by 2. Okay. So 2 cos c plus d by 2, 75 plus 35 by 2 sin 75 minus 35 by 2. So 2 cos, so what is the sum? So 110 by 2, it is what is that, 55 degree. 110 by 2, 55 degree, sin 75 minus 35, 40, 40 by 2 equal to 20 degree. Subdivision 2, it is of the form cos c plus cos d. Okay, so it is nothing but 2 cos c plus d by 2 into 2 cos c plus d by 2 into cos c minus d by 2. So 2 cos c plus d, 60 plus 15 by 2 cos 60 minus 15 by 2. Sorry my dear student, it is not 60, 65. Okay, change it, 65 degree. Okay, so 65 plus 15, 80, 80 by 2, 40. So 2 cos 40 degree, it is 65 minus 15, what is that? I think 50 by 2, it is cos 25 degree. So it is of the form sin c plus sin d. So it is nothing but 2 sin c plus d by 2 into cos c minus d by 2. 2 sin c plus d, 50 plus 40 by 2 into cos c minus d by 2. 50 minus 40 by 2. So 2 sin 90 by 2, it is 45 degree. Sin 45 degree, 50 minus 40, 10 by 2 is 5 degree. So cos 5 degree. My dear student, subdivision 4 in the question number 2, it is of the form cos d minus cos c. Okay, cos d minus cos c format. Okay, so be careful with this formula because cos c minus cos d is 2 sin c plus d by 2 into sin d minus c by 2. Usually we are putting c minus d by 2. Here 2 sin c plus d by 2. So 35 plus 75 by 2 into sin d minus c. So first this is d. So 75 minus 35 by 2. C plus d by 2, d minus d by 2. Okay, so 2 sin, so what is this again, 110 by 2, 55 degree, sin, okay, 40 by 2, 20 degree. Question number 3 in the exercise 3.6, so that sin 12 degree into sin 48 degree into sin 54 equal to 1 by 8. So my dear student, here among the 3 values, so it is the known value. So refer example number 3.29. Okay. Refer example number 3.29. There sin 54 value we obtain. It is root 5 plus 1 by 4. Okay. So it is given in example number 3.29. Sin 54 degree equal to root 5 plus 1 by 4. In the meantime, cos 36 degree also the same value, root 5 plus 1 by 4. So give both the values. Okay. So let us deal with so first take the left hand side. So LHS. So we know this value. So keep separately. So remaining, consider the remaining. So it is of the form sin C into sin D. So what is, or you can consider the bigger value as C, sin C, sin D, sin A, sin B. What is the formula? 1 by 2 cos A minus B minus cos A plus B. Sin A, sin B. Imagine it is A and it is B. Sin A, sin B equal to 1 by 2 cos A minus B minus cos A plus B. So 1 by 2 cos 48 minus 12 minus cos A plus B, 48 plus 12. So keep sin 54 the same. Okay. So 1 by 2 into, so what is this? Cos 36 degree minus cos 60 degree into sin 54 degree. So now we know that, put the known values. So 1 by 2 into root 5 plus 1 by 4, cos 60 is 1 by 2, again sin 54 is root 5 plus 1 by 4. Okay. So here take the LCM. Okay. Or you can combine with this 1 by 2 into 1 by 4, 1 by 8. Okay. Remaining take the LCM, root 5 plus 1. So minus 2 by 4 into root 5 plus 1. Okay. This 4 into 2 already combined. So 1 by 8. So root 5, 1 minus 2 minus 1 by 4. Okay. Into root 5 plus 1. Now look at these two terms. It is of the form A plus B into A minus B. It is A square minus B square. So 1 by 8 into 5 minus 1 by 4. So 5 minus 1 is 4. This 4 cancel. So 1 by 8. That is the RHS. Question number 4 in the exercise 3.6. Show that cos pi by 15 into cos 2 pi by 15, 3 pi by 4 pi by 5 pi by 6 pi by 7 pi by. The product of this value is equal to 1 by 128. That is our aim. So my dear student, so take the LHS. LHS is equal to, okay. So before solving this question, we have to remember one of the identity. It is given page number 119 in your textbook. The identity is cos 60 minus A into cos A into cos 60 plus A. It is equal to 1 by 4 cos 3A. Cos 60 minus A into cos A into cos 60 plus A equal to 1 by 4 into cos 3A. So we are going to use this identity in this question. So first look at that. 5 by 15. So what about the value? So 180 by 15, that is 12 degree. Cos 12 degree. 2 into 12, 24 degree. 3 into 12, 36 degree. So 48 degree into cos 60 degree. Cos 72 degree. Cos 84 degree. So among these 7 values, the only one is known value. Cos 60 is, okay, known value. Take it separately. So again, from the remaining, we have to combine 3, okay, in this form. Consider cos 12 degree, okay, cos 12 degree, 48 degree, 72. 12, 48, 72. So apply this formula. Consider A equal to 12 degree. So 60 minus A is 48 degree. 60 plus A is 72 degree. Similarly, consider this 24 as A. So 60 minus 24 is 36 degree. Okay. And 60 plus 24 is 84 degree. So combine these 3. So first combine cos 48 degree, cos 12 degree, cos 70 degree, one set, into, so another set, into cos, what is that? 36 degree, cos 24 degree, cos 84 degree. Now look at the combination. It is of the form cos 60 minus a, cos 60 plus a, cos 60 minus a, cos 60 plus a. So we can use this formula, identity. So 1 by 4 into cos 3a. So cos 60 is well-known value 1 by 2. So again it is 1 by 4 cos 3 into what is a here? 12 degree. So into again 1 by 4 into cos 3 into, so what is, so 24 degree. So my dear student, look at here. So 4 into 4, 16. Okay. So 4 into 4, 16. 16 into 2, 32. So 1 by 32 into cos, okay, 36 degree into cos 72 degree. 3 into 24, 72 degree. Okay. Already we know that cos 36 degree is 1 by 32 into, so root 5 plus 1 by 4 cos 36 degree. Cos 70 means it can be written as cos 90. So cos 72 can be written as cos 90 minus 18. It becomes sin 18 degree. Okay. So sin 18 degree is nothing but root 5 minus 1 by 4. Okay. So again take only 1 4. Okay. So 4 2s are 8. 4 3s are 12. So 1 by 128 into, so 1 4 is remaining. So a plus b into a minus b. A square minus b square. 5 minus 1 is again 4. This 4 cancel. It is the RHS. So you have to remember what is cos 36, what is sin 18 value. If you have the doubt, refer example number 3.29 in the textbook. Question number 5 in the exercise 3.6. Show that sin 8x into cos x minus sin 6x into cos 3x divided by cos 2x into cos x minus sin 3x into sin 4x equal to tan 2x. So my dear student, take the LHS. Again we solve many problems with the use of product to sum. It is of the form sin a cos b. It is nothing but 1 by 2 sin a plus b plus sin a minus b. So 8 plus 1 9. 8 minus 1 7x. So 1 by 2 sin a plus b plus sin a minus b. Similarly, the same formula 6 plus 3 9. 6 minus 3 3. Again cos c cos d. So it is 1 by 2 cos c plus d, so cos a plus b plus cos a minus b. So 2 plus 1 3 plus 2 minus 1 1. Similarly sin c sin d equal to 1 by 2 into cos a minus b minus cos a plus b. Order, there is a change in the order. 1 by 2 cos a minus b minus cos a plus b. So a minus b means 4 minus 3 1. A plus b 4 plus 3 7x. Okay. So both the numerator and denominator take 1 by 2 common and cancel it. Okay. So 1 by 2 take it outside and cancel it. So remaining sin 9x minus sin 9x cancel. So sin 7x I am writing directly and minus sin 3x. Similarly cos 3x, cos x minus cos x cancel. So minus into minus plus cos 7x. Okay. So again sum to product. It is of the form sin c minus sin d. It is 2 cos c plus d by 2 into sin c minus d by 2. So 2 cos 7x plus 3x by 2 sin 7x minus 3x by 2. Here cos C plus cos D, cos C plus cos D, 2 cos C plus D by 2 into cos C minus D by 2. So what is that? 7 plus 3x by 2, 7 minus 3x by 2. Now 2 cancel. The first term cos of the same value remaining 7 minus 3, 4. 4 by 2 is 2x, sin 2x. 7 minus 3, 4. 4 by 2 is 2x. Sin 2x by cos 2x, that is tan 2x. Question number 6 in the exercise 3.6. Show that the LHS cos theta minus cos 3 theta into sin 8 theta plus sin 2 theta by sin 5 theta minus sin theta into cos 4 theta minus cos 6 theta equal to 1. Our aim is to prove it is equal to 1. So take the LHS. It is of the form cos C minus cos T. It is also the form cos C minus cos D. The formula is 2 sin C plus D by 2 into sin D minus D by 2. 2 sin C plus D by 2 into sin D minus D by 2. So put C equal to theta and D equal to 3 theta. The same formula for this term. Put C equal to 4 theta, D equal to 6 theta. So we are getting both the things. And sin C plus sin D equal to 2 sin C plus D by 2 cos C minus D by 2. Put C equal to 8 theta, D equal to 2 theta. And it is sin C minus sin D. It is 2 cos C plus D by 2 into sin C minus D by 2. Put C equal to 5 theta, D equal to theta. So again these two all are in the form of product, we can cancel. Okay, and so look at that. So sin 3 plus 1, 4 by 2 is 2. So sin 2 theta, okay, 3 minus 1 is 2, 2 by 2 is 1 into sin theta into 10 by 2 5 theta, sin 5 theta into 8 minus 2, 6 by 2 is 3 theta, cos 3 theta by again cos 6, 5 plus 1, 6 by 2 is 3 theta into 5 minus 1, 4 by 2 is 2, sin 2 theta into again sin 5 theta, sin theta, 6 minus 4 is 2, 2 by 2 is 1. Okay, now look at the terms. Cancel sin theta cancel, sin 5 theta cancel, cos 3 theta cancel. We are getting 1. That is the RHS. Question number 7 in the exercise 3.6. So prove that sin x plus sin 2x plus sin 3x equal to sin 2x into 1 plus 2 cos x. So my dear student, the hint is present in the question itself. So take the LHS. So keep the sin 2x without change. Okay. Remaining sin 3x plus sin x. Okay. So combine these two. No change in the term sin 2x because it is already present in the answer right hand side. So imagine it is the form sin C plus sin D. So it is, what is sin C plus sin D? 2 sin C plus D by 2 into cos C minus D by 2. Okay. Sin C plus sin D equal to 2 sin C plus D by 2 into cos C minus D by 2. So sin 2x plus 2 into 3 plus 1, 4 by 2 is 2. Sin 2x, 3 minus 1 is 2, 2 by 2 is 1, cos x. So now take sin 2x outside. So remaining 1 plus 2 cos x, that is the RHS.